Okay, hello everyone, and welcome again to our Salt Security Founders Corner podcast. With me again today is Roy Eliyahu. Excited to have Roy on today. Roy, we're going to just jump right into it. I think you can't read anything or be online and avoid seeing something about agentic AI or AI agents or MCPs or all of that, everything kind of related to that. Maybe your perspective, like why is it become so popular, and why are so many people talking about it right now?
Yeah, so look, I think I don't want to be repetitive to what everybody is saying in the industry, but I think it's very clear to everyone that AI changed our lives, change how we build products, change how we adopt as organization, how we evolve to make it easier for our customers. And I think the evolution now of AI agents, not just AI and LLMs, like AI agents and MCPs are just creating a big wave of both innovation and value, but also creating a massive challenge from a security perspective. So I think if I put it in short, right, I think every company, every product has a lot of different systems, a lot of data sources. They have their own application, they have internal BI system, they have their Salesforce, they have like third-party services, they have all that. And I think that really the promise and the potential of AI agents, that basically it allows you to connect to all these sources through APIs and make sense of that data, all right, and be able to address so many use cases. So if I'm an airline company, instead of you as a consumer or myself want to go and check what's my upcoming flights, what's my seats, is there any delays, do I want to book a new flight, instead of having just going through a product and say search, look for it, and kind of be very structured, AI agents allow it to be much more conversational and much more intuitive by just asking like you would ask a person. Hey, I want to fly from New York to Dallas next week, and what are my options? And I want to make sure I land on by 9 p.m. I want to do this, I want to do that. And you can simply interact with it. And on the background, it's connect to all these data sources, pulling all the data, make sense of it, and just output the answer you're looking for.
Yeah.
So I think the potential is huge, which drive a massive adoption of these AI agents.
I think you're right, and I think what it does is, like, I mean, we're all probably using it to different degrees. It almost anticipates too, right? And that anticipation of what you might ask next or what you might be thinking about with access to all of these data sources, it can give you a really reasonable or a really good answer there to not just your question, but you asked this, but you may also want to know this, right? Like, what are the airlines? But you may also want to know what the weather's like. So should you pack an umbrella? Should you stuff that you might want that's related to that? So definitely like a big, it gives it the response. It almost just makes it richer, right? But that's not without, like, to your point, security risks, right? So when you open all that up and create all that, it creates security risks. And maybe talk a little bit about what you're seeing in that area.
Yeah, so let me start by providing context to a little bit about how they built, which will set the foundation to talk about, okay, what are the risks that being created as a result of how they are built. So Anthropic, the company that created Claude, looked at these AI agents in LLM, look at all these APIs and data sources, and thought, how can we make it more efficient and easier to connect an LLM, an AI agent, to all these data sources? And they thought, okay, the right way or the intuitive way is do it through APIs. But if you look at how you connect an LLM, aka like an AI agent that composes an LLM, to an API, it needs to know how the API works. It needs to know what data they can get from it. They need to know what actions they can do through it. And how we do it as humans, we do it with documentation, right? If a developer want to create it, they will read the documentation, will make sense of it, and then we'll code it. What Anthropic created is something called MCP. It's a Model Context Protocol, and essentially provide the API context to the agent. So essentially what it does, it's essentially, you can think about it as an API broker. So instead of an agent going to documentation, read it, and then creating or calling an API, the MCP provides all this context of what APIs they connected to, aka tools, what actions they can do, what data they can get from it. So it provides all this context to LLM. So when you prompt it, say, hey, I want to know what's the weather look like, or when I have flights to this and this destination from this and this dates, it sends this message through an MCP through an API. The MCP is just another API. And the MCP return says, oh, I'm connected to the weather API. I'm connected to the flight reservation API. I'm connected to all these APIs. Now I can query it for the specific dates, to the weather in these specific dates, and so on and so forth, the prices and all of these things. So that's essentially how it's built. So MCP, it's like a API broker that is connected like a spider web to all of the different APIs of internal system, external system, internal databases, you name it. And what it creates from a security perspective, it's a huge risk, because now you have something that has a master key to so many different services that can pull data from. Not talking about doing actions like deleting, updating, canceling reservation. That's like a whole different realm of potential risks. And now hackers can use it to manipulate it, because you have someone you can manipulate that has the keys, and the only thing they need is like just asking in the right way to get access to data. Also, the potential implications of implement that in non-secured way. So like any new technology, the first thing you are running to is, let's just make it work. And if it works, like that's the first priority. But if we properly built authentication on top of it, if we pull the right guardrails so it cannot pull information we don't want it to pull or expose to the end user. So there's a lot of risk that you want to make sure to govern, to first of all, discover, does that exist in my org? Do I have AI agents, MCPs connected to my services or to my data sources? What data sources are connected to? What data is exposed? Is it built securely? And do I have detections in case data that should not be extracted or being pulled from a certain system? Do I have detection if that happens? Will I get notified on it? So there's so many different needs and questions that you have this new thing that exposing your core assets in a non-governed, secured way to an end user.
Yeah. So you have access to all of these data sources that you may or may not intend to give different levels of access to, but you have access to all of them. And then the LLM learns that, like it learns the information, and it can't really unlearn. So that LLM like may have pulled in some sort of private information or banking information or what have you, and it can't unlearn that. So another query may say, well, tell me that, like, tell me that bank information. And it's not, at that point, it's not really even going to a data source. It just knows it because it's in the LLM, and it can't really forget it. So there's a lot of risk just across the board in places that maybe you don't even think about there being risk. How are you thinking about it? Like, how are you thinking about helping to manage that risk and help companies be able to take advantage of the benefits without some of the downsides?
Yeah. So I think if I'm now in a CISO position or security professional position, it's really confusing because you have so many different companies, right, that's saying to you, or different categories of companies saying, oh, I will help you secure all these agentic AI. So I want to break it to, I think, 3 components. The first one is enforcement management component, which is typically being addressed or trying to be addressed through what's called an AI gateway. So this is like the evolution of API gateway. You have another component of new startups that's saying we are doing LLM security, right? It's all focused on LLM specifically, that try to govern the model better. And there is the API component, which we are here at Salt looking to discover, govern, protect. I want to just break it down, at least my point of view on what each role of every company or every tool in that stack and what's the value of it, right? So to me, like, let's start with the easiest one. It's an AI gateway. AI gateway is exactly like API gateway, just for AI. So what's the issues with why API gateway is not sufficient for API security as an example? You can tell all your developers you must expose API through an API gateway. It doesn't mean that it actually will do it.
Right.
And what we see in reality, there is so many rogue APIs that are being exposed directly to the internet, not being managed, not being governed. And these APIs are typically the reason why companies are getting breached, not because of the ones they know about, the ones that I don't know about. Same for AI gateway. The fact that you have an AI gateway doesn't mean that every MCP server and every AI agent will be connected through an AI gateway. So the first thing is, you don't want to just to trust, you want to verify. You want to know, is it really going through an AI gateway, all these API communications? So that's number one. But of course, once you have the ability to discover that, to govern that, then you can move certain communication through an AI gateway. But it's just the enforcement point. It's not a discovery tool. It cannot discover that on its own. It's just a tool to help you govern. It's like you give you a lock, but you need to put it on all the doors. It doesn't tell you if you have doors without locks, right? It's just a lock. LLM security on the flip side, looking from the lens of, does my LLM output data it should not be output essentially, right? Does the response contain maybe data of customers or something that should not be turned to the user? I think this approach is very challenging. And the main reason why it's challenging is that the output of an LLM is unstructured data. It's just a blob of text that was composed based on different data sources, data records that have been fed to this LLM. But the output can be, hey, Roy, next week you will have a flight in this time and the weather X, Y, and Z, but it's a whole blob. And we know from the data security space that it's very hard to secure unstructured data.
Yep.
Now, that's why we believe that the most effective way to secure these AI agents and govern them is through the API component, because what's feeding this LLM? It's actually very structured data. So the output of the LLM is telling you everything I said, what's happening next week in the weather, but the input is much more structured. It's showing like data records of your upcoming reservations or potential flights. It shows you like data records of weather in specific times. So it's very structured JSONs essentially being fed to the LLM. So it's much easier to govern that in the input versus the output. Because if it's not being, like to your point, trained by the LLM, so it's not being data that going into the LLM, it can never be output. It will not guess customer information out of thin air.
Right.
So if you look at the API component, that's the component that where data being pulled from systems. That's the component that when you push data into an LLM, that's going through an API. And of course, by the way, the output is also going through an API, but just in an unstructured way.
Yeah.
So the easiest way for me is, I think you need to be able to discover all these connections. You need to govern, make sure they're going through like an AI gateway, and you'll be able to put all the controls there. But the right component to know and to ask yourself, does my LLM get data that should not be get or should not be trained on? That's on the API component. Everywhere else, it's going to be subject to a lot of errors because it's unstructured and it's very, very hard to secure that way.
Yeah, I think that makes a lot of sense because it is where the data is, and I'm using data like broadly but that is within the API is where that data is, and it has to be structured. I mean, that's how an API is written. Is there's a structure to it, right? There's pieces of it, and that's where you can analyze and understand: is this data sensitive? Should it be going to this place? Is it authorized? Is what have you? And I think the other thing you said though is these MCP servers relatively easy to spin up. Almost in a sense, like you have these rogue or shadow APIs, you could have the same thing in the MCP server side. And you want to know where it all is, right? I mean, you want to understand that entire sort of context or that fabric of where all of this information is being transmitted or read or what have you. So let me ask you specifically on that one, and then we'll wrap up this week's podcast. On the MCP servers, how do you know where they are? Like, is there a way to understand where they are in an environment?
Yeah. So first of all, let me just address the first point. Like, you're absolutely correct. Again, like I want to emphasize, we call it MCP, but we can call it REST. We can call it GraphQL. We can call it gRPC. It's just another protocol. It's an API. So when you say I expose MCP, it's like saying I'm exposing a REST API. I'm exposing an MCP API, right? Also, REST API is connected on the back end to a bunch of services. It's just yet another API being exposed.
Yeah.
Now, to your question, I'll provide some context. MCP servers can be deployed within your company that you develop, you manage, you are running and exposed to your customers. Or someone can develop an MCP server externally and connect it on the back end to your APIs without you even knowing about it. And what we see in the market right now is that there is thousands of MCP servers that we call shadow MCPs because they are developed not by the company. If it's a Salesforce, they're not developed by Salesforce. They are developed by many different developers just built an MCP server.
Yeah.
And if I'm a company using Salesforce, I can go online, look for an MCP server that was built, like an open source library, an open source MCP,
Wow.
and I can leverage it. What is the risk with it is that I can put malicious code in this MCP. So it's like a supply chain attack.
Yeah.
I can maybe call APIs in a way that the company Salesforce in that example is not intended to be used. So that's pose a big risk for the consumer of these APIs. So the first thing you want is to be able to discover all these shadow MCPs in the wild, in the internet. If I'm a company, I want to know who built MCPs for my APIs and how they're built and if they're malicious. And I want to make sure that we block malicious use and so on and so forth. So that's kind of external discovery of shadow MCPs.
Yeah.
Then you go internally and says, okay, as a CISO, as a security professional, I want to know if somebody built MCPs within my org and someone is running and exposing them, right? That's even worse because someone that built it internally has greater access to systems versus someone external that has only what the company exposed.
Yeah.
So that's even posing a greater risk. That's like an insider threat.
Yeah.
So through our discovery, right, we are here to provide visibility to all the MCPs that built internally, what they exposed, what APIs, what data, and so on and so forth. So you want to both discover them externally, but also you want to know what MCPs you built and access your internal systems within the company, not just outside of the company.
Yeah. It sounds like to a large degree. So we've built the SALT solution around these three pillars, right? This discovering what you have, governing it, making sure that it's adhering to your policy, and if it's not, some sort of alert that you're out of policy, and then protecting against attack. It's those three pillars, really: the discovery, the governance, and then the attack. It sounds a lot like what we're seeing now with AI agents and MCPs being put out, and this push to get better and faster and smarter. It's a very similar problem that we've had in the past that wasn't and isn't being solved by the current technologies, and why we're here anyway. It's just on steroids now. It's 100x bigger than it was. Is that a good way to think about it? Like it's not like a brand new security or technical problem. It's simple. It's just a magnitude or bigger than it was.
Yeah. So in my opinion, it's both. It's taking the existing pain points that already exist with API and just making it like today 10x bigger. Like I think in the next 2 years will be 100x bigger, because it's the same need of you want to discover APIs, you want to discover MCPs. You want to know what data going through these APIs. You want to know what data going through these MCPs. You want to make sure they're built securely. So it's same issues that like any other API, just a new type of API.
Yeah.
But the problem is that now, because of the value it provides to businesses, it's driving a massive adoption. So the number of API connections within a company will grow 10 to 100x over the next year or two, if not even more, actually, just because of the value it provides. So like you said, it's just making the API security problem bigger on steroids, every pillar of it.
Yeah.
The second bucket is net new risks that are being created, right? On manipulation of this LLM, on different ways that you can hack MCPs, different specific attacks for MCPs. So there is also new attacks or new needs as a result of it, of a new protocol. Like GraphQL had the new attacks that you can do for specifically that protocol. So same will be for MCPs. But you're right that the bigger portion is just the same fundamental issues. Just now you have, instead of you having 1,000 API connections, you might have 10,000 APIs.
Right.
And by the way, connected to more critical data because of the value it provides to your end user. So you have a huge driver to connect it to so many systems, which creates a bigger risk for you.
Yeah. Yeah. And I almost think of it like that's a good way that how you just said it. So I think of when companies think about deploying AI agents, it's not one agent. Right. That's why the problem becomes so exponential in a sense is you don't deploy one agent. You might deploy 500 or 1,000, right, to manage a company, depending on the size or the environment. And I think that's where it becomes so complex that you need something to be able to manage it and see into it.
And I'll just say on that, you're absolutely correct. By the way, it's we talked a little bit about MCP and the individual case.
Yeah.
But already you can see protocol like A2A, agent to agent.
Yeah.
That are essentially, you have now router agents that operate, can be dozens of different agents, giving them tasks, orchestrating them, and all of them are connecting to multiple MCPs. So it's getting way more complex. I want to start by the simple case, like one agent, one MCP, then explain to multiple MCPs, and then explain it to 10 and 20 and 50 agents, and then you have the A2A protocol. So again, like I think we'll need more than even a podcast episode to talk about all the risk there.
Yeah.
But let's do crawl, walk, run, right? The crawl part is understanding MCP, understanding how it works, understanding the risks, and then we will start to go to the run and the walk and run part, which
Yeah.
A to A and multiple agents.
Yeah. So this has been great. And I think we're all starting to see now and understand, there's this massive upside potential with what agents can do to help companies not only perform better, but to deliver better services and better experiences to their customers. But there's also this complexity in the background that's got to be managed. And anytime you have complexity, that's always a place where you have risk and where the bad guys are always going to try to attack. Thank you, Roy, for being with us today. Everyone that watches or listens to our podcast, thank you. Keep checking back. We update these every other week. So keep checking back on Salt Security. Thank you, Roy, and thank you, everyone else. And we'll talk to you again soon.
Thank you.